This is SpaceTime Series 25, Episode 98, for broadcast on the 19th of September 2022. Coming up on SpaceTime, gamma rays from dead stars in neighbouring galaxies. A new study finds it takes millions of years for volcanic super eruptions to develop. And all space tourism operations halted as Blue Origin's New Shepard explodes in midair. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers say that a mysterious source of high-energy gamma rays discovered near the galactic center of the Milky Way could have originated in dead stars in the neighbouring Sagittarius Dwarf galaxy. The findings, reported in the journal Nature Astronomy, suggest that millisecond pulsars could be generating this additional patch of gamma radiation, which has been named the Fermi cocoon. If correct, it rules out dark matter annihilation, once suggested as a possible cause, as a smoking gun signature for the presence of dark matter associated with this event. From our point of view on Earth, the excess gamma radiation source appears to line up with part of the southern Fermi bubbles. The Fermi bubbles are a pair of colossal lobes of gamma radiation spanning some 50,000 light-years above and below the center of the Milky Way galaxy. First detected by NASA's Fermi Gamma Ray Space Telescope about a decade ago, the source of this hourglass-shaped phenomenon remains unclear, but it lines up with the location of Sagittarius A star. Located some 27,000 light-years away, Sagittarius A star is the supermassive black hole at the center of our galaxy. Almost all galaxies are thought to contain a supermassive black hole at their centers. Astronomers speculate that the Fermi bubbles could be the ancient remains of material being destroyed just before it falls into Sagittarius A star. These Fermi bubbles are patched with a few enigmatic substructures of very bright gamma-ray emission, and the so-called Fermi cocoon in the southern lobe is one of the brightest spots. One of the study's authors, Roland Crocker from the Australian National University, says an analysis of the data from the European Space Agency's Gaia spacecraft and NASA's Fermi Space Telescope revealed that the Fermi cocoon is actually due to emissions from the Sagittarius Dwarf galaxy. Due to its tight orbit around our galaxy, as well as previous passages through our galaxy's disk, the Sagittarius Dwarf has now lost most of its interstellar gas, and many of its stars have been ripped from its core into elongated stellar tidal streams. Now, given that the Sagittarius Dwarf is completely quiescent, it has no gas and no stellar nurseries, there are only a few possibilities for its gamma-ray emissions, and these include a possible unknown population of millisecond pulsars and dark matter annihilations. Millisecond pulsars are the remnants of neutron stars, stars which were significantly more massive than the Sun while on the main sequence, but have long since exploded in core collapse supernovae. Now, if these stars were in close binary systems, they can be sped up by their companion stars as they draw material from them, eventually speeding up to become millisecond pulsars, and now blast out cosmic particles as a result of their extreme rotational energies. The material, mostly electrons, being fired out by millisecond pulsars, then collide with low-energy photons from the cosmic microwave background, propelling them to become high-energy gamma radiation. Crocker and colleagues say the gamma-ray cocoon is best explained by millisecond pulsars in the Sagittarius Dwarf, and that the dark matter hypothesis is strongly disfavoured. The discovery sheds light on millisecond pulsars as efficient accelerators of highly energetic electrons, as well as their antimatter counterparts, positrons. It also suggests that similar physical processes could be going on in other dwarf galaxies orbiting around the Milky Way. This is highly significant because dark matter researchers have long believed that the observation of gamma rays from dwarf galaxies is a smoking gun signature of dark matter annihilation. Crocker says the results of the study imply the need for a reassessment of high-energy emission capabilities of quiescent stellar objects such as dwarf spheroidal galaxies and their role as prime targets for dark matter annihilation searches.
The gamma rays are very energetic photons, something like 1 million times or more energetic than the photons which compose the optical light that we can see with our eyes. And to detect gamma rays, you need to be above the atmosphere because the gamma rays, thankfully for us, can't actually get through the atmosphere. The brightest source of gamma rays in the sky is actually the entire Milky Way. So the whole plane of the Milky Way lights up in gamma rays. And those gamma rays are produced when another type of high-energy particle called a cosmic ray collides with the gas which is between the stars, the so-called interstellar medium. So the biggest source of gamma rays in the sky is this diffuse globe that stretches across the sky, basically following the distribution of the stars that you can see with your own eyes in the Milky Way band.
But it's not the only source, is it? There are other sources there too, like the Fermi bubbles.
Yes, exactly. So because we can trace independently the distribution of the gas in the galaxy, we can model it out. So we can basically ask ourselves, now we're going to remove all of the gamma rays which are associated with this process which I just mentioned, which is the collision between cosmic rays and gas, and then ask ourselves what remains. And fairly soon after the Fermi telescope was put into orbit, they were very surprised to discover that there are these giant lobes of gamma ray emission which seem to emerge from the centre of the Milky Way, which go into both the north and south galactic hemispheres. So these things became known as the Fermi bubble. So there's bright, dramatically large sources of gamma ray emission in the sky. And I've been one of many people in high-energy astrophysics who have been trying to understand what the source of these giant structures is, actually. And one immediate source which comes to mind is the supermassive black hole in the centre of the Milky Way, because in external galaxies, in some external galaxies that is, these supermassive black holes are observed to be active. They're active galactic nuclei. And when they're active galactic nuclei, what's happening is that the supermassive black holes are actively accreting gas, and that accretion of gas is energizing emission across the electromagnetic band, and also typically the launching of very large-scale outflows.
So there's material falling onto the accretion disk. That material is being literally ripped apart, and there's a lot of friction created at the same time. All this is creating enormous amounts of heat and energy that's being released. A lot of this material will fall into the black hole itself, but some of it at various temperatures, some in X-rays, some in gamma rays, is being coaxed by powerful magnetic fields, we think, and it's shooting out perpendicular to the black hole's accretion disk. We see these as active galactic nuclei.
Yeah, that's exactly right. And as you mentioned, importantly, some active galactic nuclei in external galaxies are emitting in gamma rays. So with this general idea in mind that we see these Fermi bubbles emanating from the centre of the galaxy where supermassive black hole in our own galaxy sits, and that we see similar structures in gamma rays in nearby galaxies, people went after potential evidence that the Fermi bubbles were basically a result of some relatively recent period of activity of our own supermassive black hole. And with this in mind, a couple of researchers, Meng Su and Doug Finkbeiner, who were actually two of the three original discoverers of the Fermi bubbles. A couple of years after the Fermi bubble discovery paper, they released another paper where they noted that there was apparently substructure within the Fermi bubble, so that the Fermi bubbles themselves weren't presenting just a sort of uniform brightness over their area, but there were sort of ridges of gamma ray emission. And Sue and Finkbeiner in this later paper claimed that these ridges they could see in both the north and south bubble, and they sort of linear features. In fact, they were not only linear, but they were collinear. So you could sort of draw a straight line from the northern bubble feature through the centre of the galaxy and then into the southern bubble feature. So it looked like there were these, what they call jets, things which are seen in radio and other wavelengths in the external active galactic nuclei lobe. So they claimed that there were these gamma ray jets. So people were interested in that idea, and the argument went backwards and forwards to whether the Fermi bubbles really were something to do with a supermassive black hole. But the plot sort of thickened because subsequently other researchers reanalyzed the gamma ray data, and they couldn't confirm the existence of the structure in the north, which Sue and Finkbeiner had claimed was a jet. But on the other hand, everybody who went through the exercise of reanalyzing the gamma ray data was able to find this substructure in the south. So there seemed to be some sort of linear feature which is kind of stretched out and points back towards the centre of the galaxy in the southern bubble, but you can't say with any confidence there's any matching feature in the north,
so
in the northern bubble.
So the symmetry wasn't there.
So the symmetry really wasn't there, and that's a bit unexpected. It made that whole story about this being evidence of a supermassive black hole a bit harder to believe. And so because I have been interested in the Fermi bubbles, I was aware of it, and I knew of the existence of this substructure, this feature in the southern bubble. And that feature, by the way, has come to be known as the cocoon. Anyway, so a few years ago, just completely by chance, I was looking at a paper which had nothing to do with gamma rays at all. It was a paper describing observations conducted with the Gaia telescope. That's a European Space Agency satellite, which is not operating in gamma ray wavelengths at all. It's operating in some optical wavelengths, and it's tracking about 1 billion stars, most of which are in nearby Milky Way. So it can actually work out how each of these individual stars is moving. It mostly sees fairly nearby stars, but some brighter types of stars it can see at larger distances. In fact, it can even see bright stars, for instance, stars called Lyrae, variable stars. It can see them in nearby satellite galaxies of the Milky Way. So, for instance, a satellite galaxy is a small galaxy which is gravitationally bound to the Milky Way. The most famous examples of those are the Large Magellan Cloud and the Small Magellan Cloud. And because Gaia is both sensitive and can also, with extreme precision, work out the velocity of the stars that it's tracking, it can say, well, that star is basically moving far too quickly to be a member of the Milky Way. So it's somewhere beyond the Milky Way. And it's able to basically, if you're looking in any particular direction, can filter out the stars which are true members of the Milky Way from the stars which belong to an object which happens to be along the line of sight, which are basically behind, say, the disk of the Milky Way or behind the so-called bulge of the Milky Way. Anyway, so I was looking at this picture from a paper describing these Gaia data, and what this picture showed was these Lyrae stars that had been identified by Gaia and which were, on the basis of their inferred velocities, could be shown to be not members of the Milky Way. So this picture showed the stellar populations or the Lyrae populations of the Large and Small Magellanic Clouds. But then it showed another feature, and I had only been dimly aware of this thing. It showed a thing called the Sagittarius Dwarf galaxy, and the Sagittarius Dwarf galaxy is the third most massive satellite galaxy of the Milky Way. And interestingly, we haven't known of its existence for that long, only since the 1990s. And the reason why that is that this galaxy, from our position in the solar system, we actually look through the busiest part of the sky. We look towards the galactic center and actually through this old population of stars around the galactic center called the galactic bulge to see this galaxy. And it wasn't until the 1990s that people could basically filter out all of the stars in front of the Sagittarius Dwarf well enough to be able to identify that as a separate stellar structure. The Sagittarius Dwarf galaxy is a distance of something like 25 kiloparsecs away from us. So this is just the length scale that astronomers tend to use. And in comparison, that's something like 3 times the distance from us to the galactic center.
For a long time there, it was thought to be the nearest galaxy after its discovery, until we found the Canis Major Dwarf galaxy, which was even closer. The thing about Sagittarius Dwarf, I guess, is the fact that based on the Gaia readings, we think that it's crashed into the Milky Way a couple of times, and is doing so now.
Yeah, right. So it's a very interesting structure. It's the remnant of a galaxy which was once much more massive, something like maybe at least 10 times more massive than what we see now. And it's suffering because of its interactions with the Milky Way, and in particular the tidal effects of the Milky Way's gravitational field on it. And what those tidal effects have done, they have pulled out the more loosely bound stars belonging to the dark matter halo, which defines the Sagittarius galaxy. They've pulled them out into very, very long streams, so these linear structures. And those streams actually wrap around the sky a couple of times. So there are these very, very long streams of stars which have been pulled out of the original progenitor of the Sagittarius system. But there's still a core left, and that core was clearly identified in this Gaia data paper. You could see the Lyrae stars in the core of the Sagittarius Dwarf, and it sort of tickled the back of my brain because I thought, well, that's in a rather similar place to where I know this gamma ray structure called the cocoon. So I just did a very primitive thing. I just overlaid these two pictures using Keynote, and they seem to sit on top of each other pretty convincingly, and the overall orientation and shape of the stars in the core of the Sagittarius seem to match up with the shape and orientation of the gamma ray cocoon. Now, of course, that's not a very scientific thing to do, so I had to engage with people who are actually experts on Fermi data analysis, and that took a number of years, and my collaborator Oscar Macias was the main driver behind this. But basically, it was quite difficult work because of the very strong foreground of gamma ray emission from the galaxy itself that Oscar had to contend with. But after quite a couple of years of struggle on the problem, he was able to show very conclusively that indeed the gamma ray signal that we were calling the cocoon is actually the Sagittarius galaxy. the detailed spatial structure of the gamma rays is actually tracing the distribution of the stars in the Sagittarius galaxy.
And this was because of the gamma rays coming from millisecond pulsars, is that right?
Well, that's an independent question that we had to think about. So we've seen this gamma ray signal, and we think it's coming from this galaxy, which we happen from our... So just let me emphasize here that it's just completely by coincidence, according to our study, that we see this galaxy through the Fermi bubble. It's just because of the relative alignment of the between the solar system and the galactic center, from where the Fermi bubbles are emerging, and the Sagittarius galaxy. Okay, so we discovered this signal, or at least, to our own satisfaction, we've discovered the signal, and we think it's coming from the Sagittarius galaxy. And then the next question is, where are these gamma rays coming from? And that's an interesting question, because when we started talking, I was describing how we see the brightest source of gamma rays in the sky is actually the plane of the Milky Way, and that's from cosmic rays colliding with gas in the plane of the Milky Way. But that can't be the explanation for the gamma rays that we see from Sagittarius. And there's one very good reason for that, which is that there's no such gas in Sagittarius like there is in the Milky Way. So the same processes which have pulled the stars out of into these tails over the sky, this tidal disruption, and also another process called ram pressure stripping, have removed all of the gas from Sagittarius as it basically orbits around the Milky Way. So there's no target gas for this process of cosmic ray collisions to make gamma rays.
And this ram pressure stripping is being caused by the gravitational pull of the Milky Way as Sagittarius Dwarf plows through it.
Well, yeah, specifically ram pressure stripping refers to the hydrodynamical interaction between the gas in the halo of the Milky Way and the gas in the orbiting Sagittarius Dwarf. There's a sort of a frictional force that the Sagittarius gas field is, because it's pushing its way through the gas which is bound into the halo of the Milky Way, as well as this tidal effect. Anyway, so that sort of left us with two things that we could think of for the gamma rays, and one would have been much more exciting if it had been true, which is that the signal might have been a signature of dark matter annihilation. There are fairly good theoretical reasons to think that dark matter, if it's in the form of something called a WIMP, it's a weakly interacting massive particle. Dark matter in that mass range, and this has been a favoured theoretical idea for a few decades now, might be able to self-annihilate. So two dark matter particles, if they encounter each other, can annihilate, and that might produce fairly generically a gamma ray signal. And that would have been very exciting. But we're almost certain that it's not a dark matter signal, the Sagittarius cocoon gamma ray signal, because the dark matter, just like the more weakly bound stars in the progenitor of the Sagittarius Dwarf system, that dark matter will have basically been pulled out into these tidal tails which wrap around the sky. And we wouldn't have expected the very concentrated signal that we see, which is just correlated with the remaining core of stars belonging to the Sagittarius Dwarf. So basically, we're left with this idea that we have a gamma ray signal, but it's apparently coming from a population of rather old stars which aren't doing apparently very much. It's an old population of stars because, again, going back to the fact that the Sagittarius galaxy has lost its gas, it hasn't been able to make any new stars for a few billion years because it's lost all of the fuel for making new generations of stars. So you have this sort of a mature population of stars, and basically we think we're left with essentially only one candidate astrophysical source, and that's a population of things called millisecond pulsars. So these are neutron stars which are rapidly rotating, and rapidly means that they're rotating, something like 100 times a second, and they have relatively strong magnetic fields, not as strong as the magnetic fields which are typical of so-called young pulsars. And these systems are observed to generate gamma rays in other situations. So they're not very bright individually, for quite nearby, in astronomical terms, quite nearby millisecond pulsars to the Earth are observed as individual gamma ray sources. And another situation where we can detect gamma rays from millisecond pulsars is from globular clusters. So there are about 30 globular clusters in the galaxy which produce a gamma ray signal, and it's pretty well established that the gamma ray signal from all of those globular clusters is coming from the millisecond pulsar population of each of those globular clusters. So we think it's basically the same story in the Sagittarius Dwarf, that there is a population of these millisecond pulsars. The millisecond pulsars are produced by stars in binary systems. You have to have a relatively massive star, quite a few times, something like 6 or 7 or 8 times more massive than our own sun is. And that star has to have a companion in a binary, and it has to be that this binary has to be tight enough, or the two stars have to be close enough to each other that as the two stars evolve, then there can be what's called mass transfers. So one star, the donor star, loses some mass, which is then accreted onto the more massive companion. There are a couple of different scenarios for producing a millisecond pulsar, but one thing that can happen is that this accretion of gas can be what is essentially speeding up the neutron star to these very fast rotational periods. So we think there's a population of something like a few hundred of these millisecond pulsars in the Sagittarius Dwarf.
That's Associate Professor Roland Crocker from the Australian National University. And this is SpaceTime. Still to come, a new study suggests that supervolcanic eruptions take millions of years to develop, and space tourism operations halted as a Federal Aviation Administration accident investigation crash gets underway into the mid-air explosion of Blue Origin space tourism rocket New Shepard. All that and more still to come on SpaceTime. Volcanic super-eruptions are some of the planet's most violent events. They happen when magma deep in the mantle rises into the crust but is unable to break through. This causes a massive build-up in pressure in what is a large and ever-growing magma pool. Eventually, pressures become so great the crust is no longer able to hold back the enormous power beneath, and it ruptures in some of the most massive explosions on the planet. These can occur at hotspots such as the Yellowstone caldera in the western United States, or along major subduction zones such as Indonesia's Toba. To give you an understanding of their size, the Yellowstone supervolcano produced a massive caldera some 70 by 45 kilometers in size. It was formed some 640,000 years ago during the last of 3 super eruptions over the past 2.1 million years. Even more spectacular was the Toba supervolcano, which erupted some 74,000 years ago and remains the largest known volcanic eruption on Earth over the past 25 million years. In fact, Toba killed most humans living at that time, possibly leaving as few as 2,000 breeding pairs. It created a population bottleneck in Central Eastern Africa and India, which still affects the genetic makeup of the human population to the present day. Supervolcanic eruptions are very rare, only occurring once every 20,000 years or so. However, when such eruptions do occur, they cause incredible destruction on a global scale, with catastrophic consequences. The findings, reported in the journal Nature, are based on a new model of crustal flow, showing how pre-existing plutons, that is, bodies of intrusive rock made from solidified magma, were formed over millions of years prior to known gigantic super-eruptions. The research also shows that the disruption of these plutons by newly emplaced magmas takes place extraordinarily rapidly. So, while the magma supplying super-eruptions builds up over a prolonged period of many millions of years, the magma disrupts the crust and then erupts in just a few decades. The study's lead author, Steve Sparks from Bristol University, says the longevity of plutonic and related volcanic systems contrasts markedly with the short timescales needed to assemble shallow magma chambers prior to large magnitude eruptions of molten rock. The study cast doubts on the interpretation of prolonged storage of old crystals at temperatures high enough for some molten rocks to be present, and indicates the crystals had arrived from previously emplaced and completely solidified plutons. Scientists have known that volcanic supereruptions eject crystals derived from older rocks. However, before this study, they were widely thought to have originated in hot environments above the melting point of rock. Previous studies have shown that magma chambers for supereruptions form very rapidly, but there was no convincing explanation for this process. While earlier modelling suggested that supervolcanic eruptions would need to be preceded by very long periods of granite-pluton emplacement in the upper crust, evidence for this inference was largely lacking. Sparks says by studying the age and character of the tiny crystals erupted with molten rock, scientists can help to understand how such mega-eruptions occur. He says the findings provide an advance in understanding the geological circumstances which enable supereruptions to occur and help identify volcanoes that have the potential for future supereruption events. This is SpaceTime. Still to come, Blue Origin's New Shepard explodes in mid-air, and later in the science report, Australia's Bureau of Meteorology has officially declared another La Nina. All that and more still to come on SpaceTime. All space tourism operations have been halted as the Federal Aviation Administration's air crash investigators begin the long and involved process of trying to determine why a Blue Origin New Shepard rocket blew up in a spectacular fireball just 64 seconds after launching from its West Texas base.
The launch gantry retracting. We're going to get ready for our built-in test checks, our bit checks, and make sure all of the subsystems on the rocket are ready to go. The aft fins rotating, those fins at the base of the booster, help direct the vehicle on ascent and descent. The engine nozzle gimbaling. Now that engine gimbals to help maneuver the rocket as it flies. We're also keeping an eye on the pressure and the temperature in the propellant tanks. Those need to stay in the start box or the green zone for all of these different variables. All right, everything looking good with the rocket. It is time to hand it off to mission control. Let's launch New Shepard.
T-minus 10, 9, 8, 7, 6, 5, 4. Command engine start. 2, 1.
Mission control confirms New Shepard has cleared the tower and is headed to space. We're gaining speed. As New Shepard gains altitude, the atmosphere gets thinner. Now, we actually started at about 3,700 feet MSL. That's how far above mean sea level we are out at Launch Site 1. That BE-3 engine throttled up as we're going to push up to max Q.
The booster appears to have failed at an altitude of 27,440 feet. That's almost 86 kilometers, and shortly after passing through max Q, the point of maximum dynamic pressure on the spacecraft during ascent. The rocket appears to have been throttling back up and was accelerating through 1,000 kilometers per hour when flashes were seen in the booster's rocket engine exhaust plume, suggesting some sort of debris in the combustion chamber, a condition known as engine-rich exhaust. This was followed by a catastrophic explosion, ripping the launch vehicle apart in a fiery plume. The crew vehicle escape system successfully jettisoned the unmanned passenger capsule, which for this mission was loaded with scientific experiments. After a high G departure from the fireball beneath it, the passenger capsule gently floated back to the ground under 3 parachutes.
It appears we've experienced an anomaly with today's flight. This was unplanned and we don't have any details yet, but our crew capsule was able to escape successfully. We'll follow its progress through landing. The drogues have deployed, and the mains are going to be pulled out next. All right, the mains are out. They're reefed. They're going to be expanding. As the mains inflate, the capsule will stabilize. That's looking like a successful execution for the crew capsule and escape system. And the crew capsule continuing to descend under its 3 main chutes. As we come down towards the desert floor, we're going to expect that retro thrust system to fire. Again, that will take out most of the energy in the landing in addition to the parachutes. There goes the retro thrust system.
The remains of the booster impacted on the ground within the designated hazard area. It was the 23rd mission of New Shepard, which is named after Alan Shepard, the first American in space. The flight, which was carrying 36 scientific experiments, was originally slated to launch in late August, but was delayed by bad weather. Blue Origin began flying space tourists aboard New Shepard last year. All flights have now been placed on hold, pending the outcome of the FAA's investigation. With tensions at boiling point in Ukraine and the Taiwan Straits, the US military has test-fired an LGM-30G Minuteman III intercontinental ballistic missile. The nuclear-capable rocket was launched from the Vandenberg Space Force Base in California. The U.S. Defense Department described the launch as part of routine and periodic activities intended to demonstrate that the United States nuclear deterrent is safe, secure, reliable, and effective. The 18.3-metre-long 3-stage Minuteman III are usually equipped with 3 MIRVs or multiple independently targeted re-entry vehicles. These can be either W62 Mark 12 170 kiloton or W56 1.2 megaton thermonuclear warheads. The test missile was equipped with 3 dummy warheads for this exercise. The Minuteman III ICBM has now been in service with the United States for 50 years, replacing older Titan and Atlas missiles. They're housed in an array of underground missile silos spread across Wyoming, North Dakota, and Montana. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. Australia's Bureau of Meteorology has now officially declared another La Niña spring and summer, the third such event in a row. La Niña weather patterns are associated with heavy downpours and widespread flooding along Australia's Pacific coast. The new warning follows soaking rains during the 2021 and 21-22 summer seasons. The Bureau says tropical Pacific Sea surface temperatures have been cooling since June and are now at La Niña thresholds. Atmospheric indicators, including the Southern Oscillation Index, trade wind strength, and equatorial cloudiness, are also displaying typical patterns for a La Niña event. The Bureau says climate change is continuing to influence weather patterns both globally and locally on Australian skies. In fact, Australia's climate has warmed by around 1.47 degrees Celsius since 1910. And while the Pacific coast gets wetter, southern Australia has seen a reduction of between 10 and 20% in cool season rainfall, that is, between April and October. Chaz Keys, the former Deputy Director General of the New South Wales State Emergency Services, says a third La Niña should be a real wake-up call to governments to stop dragging their feet on measures needed to protect communities. A new study warns that simply taking vitamin D and omega-3 supplements will not reduce frailty in old age. The findings, reported in the Journal of the American Medical Association, are based on examinations of some 26,000 healthy adults over the age of 50. Frailty can lead to increased risks of fractures, hospitalizations, and death. And the Mediterranean diet has been shown to reduce frailty in old age. So researchers set out to figure out if simply taking vitamin D and omega-3 supplements would have the same effect. They found that compared to a placebo, there was no difference in participants' frailty score after 5 years of treatment. An accompanying editorial says, while taking the supplements is not supported by the research, shifting attention to an active, engaged lifestyle and a Mediterranean diet might improve longevity, reduce heart disease, dementia, and diabetes. And perhaps most important for older adults, reduce frailty and loss of independence. A new study has concluded that the donkey was domesticated some 7,000 years ago, around the same time that the Sahara became the desert region we know today. Donkeys have shaped the history of humankind, both as a source for power for farm work and for transportation in sometimes hard-to-reach areas. The new findings, reported in the journal Science, are based on a detailed analysis of the genetic background of 207 contemporary donkeys living on all continents, as well as those of 31 early donkeys and 15 wild equids. The study found that donkeys first appeared in Africa around 5000 BCE. It was only 2,500 years later that they reached Europe and Asia, where the species went on to develop the lineages that we still see today. The Australian Federal Court has rejected an appeal by anti-vaxxers against an earlier court judgment which found that the group had no standing to represent members of the community. Tim Mendham from Australian Skeptics says it's an important result and an expensive loss for the anti-vax movement.
Yeah, they put in a case to stop childhood vaccination against COVID, and they took that to court, a federal court, I think. They got thrown out. They didn't even get to actually discuss the case, mainly because the judges decided that the Australian Vaccination Network, or as we call it, the Anti-Vaccination Network, had no standing, and that's the actual legal term. They had no standing in the community or to represent members of the community. So that really hit their ego a bit. Basically, they said this is all in your head that you're an important organisation and you represent other people's views. And so they threw the case out instantly, and because of awarded costs. If you're going into a federal court, you've got pretty substantial costs. They were going up against the Department of Health, basically. So the Department of Health dragged their big gun lawyers out to talk about it. So because of that, the AVN decided to appeal, and they went to the federal court. And with 3 judges there, they said, no, they were perfectly right to reject you in the first place, so they rejected again. In fact, they found the case being put forward forward was incompetent, which is apparently a legal term. It doesn't necessarily impinge on or sort of reflect the individuals involved. So they said that they were not impressed with the case being put forward. So thrown out again, costs applied again, but at the same time, AVM has raised close to $650,000 to cover this particular case.
It came from a crowdfunding site, didn't it?
It was a crowdfunding site called Give, Send, Go, which is actually a Christian crowdfunding site. Yeah, so they raised that amount of money. They'll probably continue. They've had a number of these sort of court cases and things that they raised before, and they haven't done very well with them.
That's Tim Mindham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuart-gary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuart-gary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.